Alright guys, so today we're going to talk about special right triangles. And again, this is just a review of some of the things that you've already seen in previous classes, specifically Math 2 or Geometry. So special right triangles, we have two types. Right? The first type of special right triangle is what we call a 45, 45, 90. Right? And so this triangle is got a special relationship with the specific angles and side measurements. So let's draw a little right triangle here. And so in this right triangle, again, both of the degree measurements are going to be 45 degrees. And of course we have to have a 90-degree triangle because it's a right triangle. So again, 45, 45, 90. And because of the way that this triangle works, this is actually called an isosceles triangle, which means that if you have two angles that are exactly the same measurement, that the sides opposite those angles also have the same measurement. And so we're going to call this side x, which means this side also has to have the length x. And now something special that happens is that when we do the Pythagorean theorem to find the length of this measurement, what we end up with is x times the square root of 2. And what that really means is that whatever the length of this side is, we would multiply by the square root of 2 to get the length of the hypotenuse. And so let's look at a couple of examples of how that could work. Just to kind of remind you of what that looks like. Okay, so for example, again, let's draw ourselves a right triangle. Okay. And I'm going to label one side 45 degrees, or one angle. And again, as long as we have one angle that is labeled as 45 degrees, or we are told it's a 45, 45, 90, then I know these characteristics. So again, right angle always points to the hypotenuse. All right. And I'm going to call this side C for today. And I'm going to make my side measurements both 4. So now if this is my triangle and I want to look at the relationship, if I want to find the length of side C, because the legs or the sides of my right triangle both have the same measurement, which you can see, the hypotenuse is going to be whatever that side is times the square root of 2. So I would say that this side measurement is 4 times the square root of 2. And so I don't have to use the Pythagorean theorem to find the length of a side. If it is a special right triangle, I can just use the characteristics. So let's look at another one. Right. Again, what if I don't label both of the sides? I label a side and a hypotenuse. So let's label this right here. I'm going to call this letter E and this side letter F, and I'm going to label this as 9 root 2. So again, let's look at the characteristics. Now I know that I labeled both of these sides E and F, and that's fine. We can call them XY, EF, but I'm also going to say, yep, this is also a 45-degree angle. And I didn't label this originally. I put these little tick marks. And again, when I put these little 2 tick marks on there, that tells me also that those are the same measurement. Kind of how I described when we were first talking about this triangle. And so if this says 9 root 2, and I know that is the same thing as the value of the side times the square root of 2, then the length of the side has to be the value 9, which means that E is also the value of 9 based off of the characteristics, and so is F. So again, I'm not doing any Pythagorean theorem. I'm using characteristics to try to find the values of the sides. Now let's look at kind of an oddball one, just kind of our last one for 45, 45, 90. And so what happens if I have a side that already has a square root in it? All right. So again, I'm going to know that piece of information. And I'm going to say this is 10 root 2. And I'm going to label this side x and this side y. Now, one thing I already know is that because the two legs in a 45, 45, 90 have the same value, automatically I would know that y is the value of 10 root 2, just because of those characteristics. But now I have to remember that x is supposed to be the value of the side times the square root of 2. Now it's okay that there's a root 2 here already. Take the value of your side, right, which has a square root in it, and you're going to multiply still by root 2. So this is the side times the square root of 2. Now again, you need to use some of your knowledge of how radicals work, because really the root 2 times the root 2 is the same thing as saying 10 times the square root of 4, because your characteristic of radicals is that two radicals being multiplied together can be multiplied underneath the same radical. The square root of 4 is 2, so this is really the same as 10 times 2, or 20. And so some of this is going to require you to do the characteristics of special triangles, and some of it is going to need you to use some knowledge of other math, like I said, some rules for radicals. So this is one type of special right triangle. So if you see a right triangle that is told to you it's a 45, 45, 90, if you're told that it has a 45-degree angle, or if they use these two little tick marks, then you can utilize these characteristics. All right? Now the other type of special right triangles is what we call a 30, 60, 90. All right? So in a 30, 60, 90 triangle, the name tells you the degree measurements of the triangle. So again, there's my 90. And again, always points to the hypotenuse. And now, in this type of triangle, one of these angles is 30 degrees and the other is 60. And for the moment, it doesn't matter which one I label which. I just need to be able to label so that way I can show you the characteristics. Now, in a 30, 60, 90 triangle, right, the side that is opposite the 30 is the shortest side, so we will label that x. All right, and I'm going to write that information down. Right, the shortest leg, right, this is the side that is always opposite the 30-degree angle, and that is going to be just a generic x. We can call it any variable we want, but let's just call it x. Right. Now, the longest leg, not the longest side, but this other leg, which we call the longer leg, is opposite the 60. All right, so I'm going to say the longer leg. This is the side that is opposite the 60 degrees, and this has a value of x times the square root of 3. So I'm going to label that all the way over here. All right. And now the hypotenuse, this is always the longest side. No matter what, the longest side of a triangle is always the hypotenuse. And this is the side that we say that is opposite 90. And this has 2 times x as its ratio, or its characteristic. So now, depending on what information we have, you can see each side has a value for x in it, but we have some other factor attached. So we're just going to look at a couple of examples. All right. So for example, let's just give ourselves a little triangle. And now with this one, it's going to be super important that we know which angle is the 30. All right, so what I'm going to do is I'm going to write this angle down here is 30 degrees. And this angle up here is 60. And I'm going to say this side right here is 5. And I'm going to call this F and this G. And so sometimes you get these triangles which have different variables just to let you know, hey, I want to find the length of this side, and we're going to call it that variable. So again, let's just look at what we've got. All right, I've got a 30-degree measurement, and the side opposite the 30-degree measurement is 5. So what I'm going to do is I'm going to say that in my my characteristics here, if this is 5, then the longer side is going to be 5 times the square root of 3. I'm sorry, the longer leg is 5 root 3, because that means the side opposite 60 is whatever is x times root 3. All right, well, that's the side opposite of the 30 times the square root of 3. That means that G is the hypotenuse, or the longest side, and that has the characteristic of 2 times the shortest leg, which is 10. And so what I'm doing is I'm just using those characteristics of the sides that are opposite those specific angles and these values here that are given to be able to solve my triangle. All right, so they can get more complicated, obviously. All right, but we just want to kind of understand how these work. And so again, what if I just put this side as, or this angle as 60 degrees, call this side x, this side 10, and this side y. Well, again, I like to look at this and say, well, that means that this right here is my hypotenuse. Right? If it's not labeled, this is the side that is also a 30-degree measurement. And so right now, my 30-degree measurement is opposite and unknown. So what I have to do here is I have to look at the side that I'm given, which is opposite the 60. And so this value here has the value of 10, but that has x times root 3 as its ratio. And so what I need to do is I need to set that side length equal to the ratio, or the the characteristic, so I can solve for x. And so now if I divide by root 3, that means that x is the value of 10 root 3. And something that you're going to have to think about is rationalizing the denominator. So we're not allowed to have radicals in this denominator, which means we need to multiply top and bottom by that radical. And when we do that, in the numerator, now what we get is 10 times root 3. But in the denominator, square root of 3, square root of 3, that's square root of 9, which is just 3. And so way over here, this side is going to be 10 root 3 over 3. And so rationalizing denominators is going to be super important, so that way we can get a more expected or simplified value. But we would now be done with that side. Now the hypotenuse has the value of x times 2. And so really this side right here, which was my y, my value for y, you have to remember that's 2 times whatever happened when I solved or came up with x. And so now that hypotenuse is really 20 root 3 over 3. Okay, so again, using some of those characteristics, I want to be able to find the different sides. And this is probably one of the more difficult ones, just because you're trying to set something up. And so let's just do one more quick one. I know kind of going a little bit fast, but again, we can always rewatch these videos. This is just a reminder of how these type of triangles work. All right. And so you definitely always want to be able to go back, pause it a second, say what is really happening here. All right. And so I'm going to label some different values, and I'm just going to call this 30. And sometimes that's all you get. All right, you don't really get a lot of information sometimes. So again, when I think about my characteristics, I want to realize that the side that is opposite the 30-degree angle, that's like my unknown. All right, this is what we're considering the side, or the x. That's good. When I've got that side, that's great. Which means that the 60, this right here is going to be the same value of 5 root 3 times the root 3. All right, so you have to remember the longest leg, which is opposite 60, is always side times root 3. But again, this is the same thing as 5 root 9, or 5 times 3, which is 15. So you don't necessarily have to do all of that work to get to that value. You can do a little bit of that mentally. Right? But then this side has the value of 2 times the shorter side. And again, that makes that 10 root 3. Right? So these are the characteristics of your 30, 60, 90, and this is how you would want to solve the different sides of the triangle. Now again, this is only going to work when you have a 30, 60, 90. But again, you want to look at these characteristics up here at the top. And you want to be able to remember these very specifically, because you are going to be required to know these characteristics and how to solve for the different lengths of the sides.